Hello. Let's do some more games involving nature and uncertainty. In this game, nature first decides to go left or right, and he goes left with probability 0.5 and right with probability 0.5. Player 1 then has the option of going up or down. He can do that if he's on the left or the right. I've decided to give these the same name. It doesn't really change anything. Then once player 1 is moved, player 2 moves, but player 2 doesn't know everything. Player 2, if player 1 picks up, player 2 knows that player 1 picked up, but doesn't know if he's on the left or right. Similarly, if player 1 goes down, player 2 doesn't know if player 1 is on the left or right, but does know that player 1 picked down. So again, this oval means that you don't know where you are in this. So basically, player 1 observes what nature does. Player 2 observes what player 1 does, but does not know what nature did. Why don't you pause the video and figure out what you think should happen in this game? Okay. Here's what I think should happen. So the easiest thing to do in these kind of games is to start by looking for dominant and stupid strategies. So let's look at player 2 if player 2 is in this information set. Player 2 would say, well, it's true. If I'm here, I know that down was played, but I don't know if I'm on the left or the right. But if I were on the left, the best move would be L, because 18 is greater than 2. And if I was on the right, the best move would be greater than L, because 15 is greater than 7. So yeah, it's true that if I'm here, I face uncertainty, but really, no matter what's going on, I'm better off with L than with M, so I'm picking L. Up here, something similar happens. Player 2 would say, well, yeah, I don't know if I'm here or here, but if I were here, I'd want Y, because 10 is greater than 1, and if I were here, I'd also want Y, because 11 is greater than 0. So if player 2 is here, player 2 would say, yeah, I don't know where I am, but wherever I am, Y is the best move, so I'm going with Y. Player 1, if player 1 were here, he would say to himself, well, down is going to lead to 5, no matter what. Up will lead to 0 or 2, dependent upon player 2's actions. Wait a minute, 5 is always better than 0 or 2, so player 1 would say, regardless of what player 2 ends up doing, I want to go down if I'm on the left. Now, if player 1 is on the right, he would say, well, down leads to 4 or 12, depending on what player 2 would do. Up leads to 1, no matter what. So I'm always going to want to play down. If I'm on the right, down is a dominant strategy for me, so I'm always going to play down. So we put that all together. If nature picks left, we end up here. That happens half the time. If nature picks right, we end up here. That happens half the time. So this was a very easy game to solve. Of course, other games with this structure are not so easy to solve. So this one is a little bit harder. Could you please pause the video and figure out what you think will happen in this game? Okay. Let's start with easy stuff. So what's the easiest thing? I think if player 2 is down here, it's easy to know what will happen. Because player 2 would say, if I happen to be here, I'd rather have L, because 18 is greater than 2. And if I happen to be here, I'd also rather L, because 15 is greater than 7. So player 2 in this information set has an easy move of picking L. What about player 2 in this information set? Player 2 would say, well, if I knew I was here, I'd want Y, because 10 is greater than 1. And if I knew I was here, I'd want Y, because 11 is greater than 0. So that makes X stupid and, by the way, M stupid. So player 2 would then say, okay, I want Y if I'm in this information set. Even if I don't know where I am, I know Y is always the best move. What about for player 1? Does player 1 have a dominant strategy if he's left? Well, up can lead 12 or 2. Down can lead to 5. So no, dominant strategy for player 1, if he's a lefty, would have to mean regardless of what player 2 does, he's always better off doing, either up or down. But he doesn't know what he needs to do until he first figures out what player 2 is going to do. What if player 1 is a righty? Well, up can lead to 1 or 15, down could lead to 4 or 12. That means he can't be sure what he should do until he figures out what player 1 is going to do. Sorry, what player 2 is going to do. Fortunately, though, it's easy to figure out what player 2 is going to do. So player 1, when he figures out what player 2 is going to do, will say down will lead to L, which leads to 5. Up leads to Y, which leads to 2. 5 being greater than 2. 1, if he's a lefty, is going down. Player 1, if he's a righty, will say, well, up would lead to Y, which leads to 15. Down would lead to L, which leads to 4. I'd rather go up and get the 15. So the parties will end up here if nature picks left, and they'll end up there if nature picks right. Still, that wasn't that hard of a game to solve. Let's go on to another. You might want to pause the video and try to figure out what's going to happen in this game. Okay. Let's see what we know. Well, does player 2 have a clear strategy without having to think about what player 1 is going to do if he's in this information set? Well, if he was on this side, he would want L. If he was on this side, he would also want L. So player 2 is going to pick L, even though he doesn't know where he is, because L is always better, because again, 13 is greater than 8 and 15 is greater than 7. If player 2 is up here, does he know what to do without figuring out what player 1 is going to do? Well, if he somehow knew he was here, he would want X because 16 is greater than 10, but if he knew he was here, he'd want Y because 42 is greater than 12. So player 2 doesn't know what he would do if he is here until he first figures out what player 1 is going to do. Now let's turn to player 1. Does player 1 have a dominant strategy if he happens to be here, if nature picks left? Well, up will lead to 12 or 2, and down will lead to 15 or 20. Yes. Player 1, if he's a lefty, has a dominant strategy of down. The reason is if you go down, the worst thing that can happen to you is you get 15. If you go up, the best thing that can happen to you is 12. So you're always better off going down. Or more mathematically, this number and this number are both greater than this number and this number, making down a dominant strategy. What about player 1 if he's a righty? Does he have a dominant strategy? Well, down could lead to 4 or 17, and up can lead to 1 or 15, so no. Player 1 does not have a dominant strategy. Just to say why, I mean, again, dominant strategy means no matter what the other player does, you're always better off doing your dominant strategy. So the reason down is not a dominant strategy is, well, it's possible if player 2 were to play L, if down was played, that down would lead to 4, and if he played Y, if up is played, up could lead to 15. So that means down isn't a dominant strategy, and you know, clearly up isn't a dominant strategy, because if you go up, you might get 1, whereas if you went down, it's possible you could get 17. Okay, so what's our next step? We figured out this, and we figured out this. The next step, I think, is for player 2 to say, you know, player 1 who's a lefty has a dominant strategy of down. Player 1 who's a righty does not have a dominant strategy. So player 2 should say, the only player that has a chance of playing up is righty. Because I know there's no way this guy is going to play up. So if I'm told up has been played, I'm going to believe that it was righty who did it. And if it was righty who did it, well, I'm going to play Y, because 42 is greater than 12. So then the last thing we have to decide is, what should player 1 do if he's a righty? Well, now he knows up leads to 15, whereas down leads to 4, so he's going to go up. Okay. Let's do another game. Again, please pause your video and try to figure out what's going on. Okay. So let's see what player 2 should do. If player 2 were here, he would say L is better. If he were here, he would also say L is better. So player 2, although player 2 faces uncertainty, always better off with L than with M if he's down here. So player 2 we know will play L right here. What about if player 2 is here? Well, if he knew he was here, he'd play y, because that's, of course, a really big number compared to that. But if he was here, he'd play x. So we can't be sure what player 2 will do until we figure out what player 1 will do. Now, player 1, if he goes up, if he's a lefty, if he goes up, he gets 22 or 25, whereas if he goes down, he gets 20 or 15. This means that player 1 has a dominant strategy of up if he's a lefty. Because again, going down, the best you get is 20. Going up, the worst you get is 22. So you're always better off, player 1, going up if you're a lefty. What about if you're a righty? Well, going up can give you 1 or 15. Going down can give you 2 or 16. So no, this is not a dominant strategy. So this word is, again, not a dominant strategy. Because it's possible, again, going up could give you 15, going down could give you 2, which meant up would be better, or it's possible going down could give you 15 and going up could give you 1, which meant down is better. So far we know this L and this up. Now what should player 2 do? Player 2 will say to himself, well, I know player 1's going to go up. So if I'm told up is played, maybe I'm here, but I don't know, maybe this guy is also going to play up. What should I do? Well, that's why I made this number so big. See, player 2, right, he's going to say, maybe it's just the lefty who's played up, at which point I really want y because I want a chance at this big number. What if both play up? We could work out the math, but clearly you're going to want y, right? If there's a 50% chance you're here and a 50% chance you're here, you're still going to want to play y because I made this number so absurdly big. So player 2, definitely going with y if up is played. We know that because player 1 is a lefty is going up. So now the final thing to figure out is what should player 1 do if he is a righty? Well, if he goes up, he gets 15. If he goes down, he gets 2. He should play up. And so the parties will end up here half the time and here half the time. Thank you very much.